In this video, we are going to be talking about the second and higher derivative. And in this video, we are going to be showing ourselves how to determine the turning point of a function and how to determine the maximum and a minimum points of a function. You see, second derivative of a given function is the derivative of its first derivative. And the third derivative of a function is the derivative of the second derivative, and so on and so forth. Mathematically, we represent the second derivative as, remember that the first derivative is given as the y upon the x, which is expression of y with respect to x, or we can say that f prime x. The second derivative is given as the squared y upon the x squared, depending on the variables that you are given. Your variables can be y and x, your variables can be z and w, your variables can be t and f, and so on and so forth. And it can also be f prime prime of x. The third derivative will be the cubed y upon the x cubed, and that will be f prime 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 of x, and so on and so forth. So this one is the first derivative, this one is the second derivative, this one is the third derivative, and so on and so forth. So we have them like that. Now, let us take for an example. Let us say that we have our y to be 4x to the power 3 plus 2x squared plus 3x minus 2. We are now asked to look for, let us say, find the 4y upon the x4. That's what we are asked to find. Remember, I told you the first derivative is the differentiation of y itself. So I'm going to be having the y upon the x will be equals to 3 multiplied by 4, that is 12x squared, plus 2 multiplied by 2, that is 4x, plus 3. That is the answer for our dy dx, right? Now, the squared y upon the x squared is now given as the derivative of this first derivative, which means if you are asked to look for the squared y upon the x squared, you are going to differentiate twice, you understand? And that will be giving us 24x plus 4, right? Which means our the cubed y upon the x cubed, which is the third derivative, will be given as what? Will be given as 24, because differentiating 24x, you are going to get 24. Differentiating 4, you are going to have 0. I'm sure that we understand that. And the 4y upon the x4 will be equals to 0 like that, because differentiation of 24 itself equals to 0, which means we have our fourth derivative of this particular function to be 0. So that is how it goes. Whenever you are asked to look for the higher derivative of something, just have it in mind that what? Just have it in mind that you are going to be having we are going to keep differentiating. You understand? Let us take for an example. We have our y to be equals to exponential x sine x. We're now asked to look for the what? Let's say we are asked to look for the squared y upon the x squared. What's the first thing we are going to do? We are going to look for the what? We are going to look for the dy dx first. In the dy dx of this case, the y dx, we see that the relationship between this particular two this thing is multiplication. So we are going to use product rule. We can only use product rule, where our u is exponential x and our v is sine x. Our du upon the x equals to exponential x, and our dv upon the x equals to cos x, right? Equals to cos x. And remember, the y over the x equals to what? Equals to v du upon the x minus u dv upon the x, right? For plus u dv upon the x for product rule, right? Therefore, my dy upon the x will be equals to v du, that is v. What is my v? That is sine x, du multiplied by exponential x, which means I'm multiplying these two together, then plus v u dv, that is exponential x multiplied by cos x. I have my exponential x here, I have my exponential x here, which means I can factorize out, which means my dy dx is exponential x into bracket sine x plus cos x. That is my first derivative, the y upon the x. That's my first derivative. What is now my second derivative? I'm going to continue, just like the way I've continued before, right? I'll just say that since my dy upon the x equals to my dy upon the x equals to what? Equals to exponential x into bracket cos x plus sine x, which means the squared y upon the x will be given as what? My u, I'm still going to use product rule because the relationship between exponential x and everything inside this place is uh is multiplication, which means my u, my d squared y upon the x squared. In this case, my u is equals to exponential x and my v equals to cos x plus sine x, which means my du upon the x will be equals to exponential x and my dv upon the x will be equals to differentiation of cos x will give us minus sine x plus differentiation of sine x will give us cos x, right? Which means in this case, I'm going to say v du. You understand? V du, that is v multiplied by this. That is exponential x multiplied by cos x plus sine x, right? Plus u dv, that is still exponential x multiplied by minus sine x plus cos x. So I have this. I just add the both of them together. So I can clean off this one so that I can have my clear answer here. So I can have my clear answer. So I can decide that I want to open my bracket. You understand? I can decide I want to open my bracket. In opening my bracket, I can have equals to exponential x cos x plus exponential x sin x minus, because of this minus that is here, minus exponential x sin x plus exponential x cos x, right? Because exponential x multiplied by cos x equals to exponential x cos x. So this is positive exponential x sin x can cancel out negative exponential x sin x, which means my answer is going to be given as exponential x cos x, right? Plus exponential x cos x. Exponential x cos x plus exponential x cos x is going to be giving me 2 exponential x cos x, which means this is my answer for this particular question that I have the second derivative. You can now try. You can look for the third derivative. You can look for the fourth derivative. You understand? Now, let us take another example. Let us say that y equals to sine x. Let us say that y equals to sine x. And I said, find the 4y upon the x4. And let me say the squared y upon the x squared. These are two things that we're looking for. So we are going to look for the squared y upon the x squared first before we look for the 4y upon the x4. You understand? Now, how are we going to do this? Same way we have been doing it. We know that for our y to be sine x, our dy upon the x will be equals to what? Will be equals to cos x. Our d squared y upon the x squared will be equals to minus sine x, which means what's our y? Our y is sine x. It means that our d squared y upon the x squared equals to minus y. You understand? So we can be given option, what is our d squared y upon the x squared? It can be y, it can be minus y, and so on and so forth, which means my d squared y upon the x squared equals to minus y. You understand? I get him. Now, our d cubed y upon the x cubed will be equals to what? Will be equals to minus sine x multiply minus sine x in the differentiation of minus sine x will give us what? Will give us minus cos x. Minus cos x. And the 4y upon the x4 differentiation of minus cos x will give us what? Will give us sine x. You understand? Which means What is our y? Our y is sine x. It means that the 4y upon the x4 equals to y. That's what you're trying to say. So in summary, we say that our y equals to sine x, our d squared y upon the x squared equals to minus y, and our d cubed, the 4y upon the x fourth equals to what? Equals to y. So that's the answer for the question that we have there, and that is how we look for higher derivative. That's how we solve for higher derivative. Now it should be noted that this higher derivative concept is applicable, or this knowledge of differentiation is applicable in physics as well. Remember that velocity is the change in the change in speed, right? Or the change in displacement over time, over change in time. But we can say that velocity equals to dx, which is the change in displacement upon the t. So we can, to look for velocity, we can differentiate our displacement with respect to time. To look for acceleration, we can differentiate our velocity with respect to time. In fact, acceleration equals to the squared x upon the t squared. Why? Because it is the second derivative of the x itself, the x upon the t itself. And we can see examples. I'm going to bring out some examples that we can solve now, and we can use it as an example. You understand? Let us take for an example. A particle starts from rest. A particle starts from rest at point A and move to point B. Now, during this motion, its velocity is recorded in velocity meters per second. And it is given as, the velocity is given as 9t raised power 2 minus 2t raised power 3. That's what the velocity is given as. They now say that we should calculate the time taken for the particle to move from point A to point B. We should calculate the time taken for the particle to attain its maximum velocity and the maximum velocity that is being attained. Not hard. You see, at point B, the final velocity will be 0. You understand? The final velocity will be equal to 0. It means that our 9t squared minus 2t raised to our 3 will be equal to 0. That's what we are trying to say. Now, if you look at it very well, we can factorize out t squared from this. We can factorize out t squared. It means that t squared, if you factorize it out, we're going to be having 9 minus 2t equals to 0, right? It means that our t squared can be equals to 0, or our 9 minus 2t can be equals to 0. If you root this one, it means that our time can be equals to 0, which is practically not possible in this case, or our time can be equals to 2t. Divide both side by 2, divide both side by 2. It means that our time, the time taken to reach point B, equals to 9 over 2, which is 4.5 seconds. That's the time taken for us to move from point A to point B. You understand? Now, they now say that the maximum velocity that is attained. The maximum velocity that is attained. Now, to look for the maximum velocity that is attained, the first thing we have to look for is the acceleration itself. You understand? We are going to look for the time taken for the particle to reach its maximum velocity. You understand? To reach its maximum velocity. Now, we understand that our velocity equals to 9t squared minus 2t raised power 3, right? Our acceleration will now be equals to what? Will be equals to dv upon dt, which is differentiation of all of this, and that is going to give us 18t minus 6t squared. You now see at a maximum velocity, acceleration equals to 0. We have to understand that. It means that 18t minus 6t squared will be equals to 0. And if I factorize the common factor, that is t into bracket 18 minus 60 will be equals to what? Will be equals to 0. It means that my time can either be equals to 0, which is not possible at maximum velocity, or my 18 minus 60 can be equals to 0. Take this one back, it means that 18 will be equals to 60, divide both side by 6, divide both side by 6, it means my time will be equals to what? Will be equals to 3 seconds. At maximum velocity attained. It means that at time equals to 3 seconds, as time equals to 3 seconds, that is where I attain my maximum velocity. That's what we are trying to say. You understand? They now say we should calculate the velocity at the maximum velocity, the maximum velocity attained. That's what we want to calculate. The maximum velocity that is attained. You understand? Now, how do we do that? We are just going to say that what? We are just going to say that Vmax, since our velocity equals to 9t squared minus 2t raised to power 3. And we know that the time at which you attain our maximum velocity is 3 seconds. It means that that is equals to 9 multiplied by 3 squared minus 2 multiplied by 3 cubed. And that is equals to what? That is 9 multiplied by 9 minus 2 multiplied by 27. And that is going to be giving us what? That is 81 minus 54. That's equals to what? That's equals to 27 meters per second. That's our answer for this particular question. And that's how to look for that's how to use the knowledge of differentiation in solving for what? In solving for problems, especially in physics. You understand? Now, let us take for an example. Let us say that we have something like they said a body moves in a straight line so that the distance moved is in s centimeter, or the displacement of the body from point A to point B, from point A to point B is given as s meter. You understand? S in meter. Now the s is now given as t raised to power 3 minus 2t plus t. They now say we should find the speed of the body as well as the acceleration of the body as well. So we are looking for the speed of the body at time t and the time at which the body is at rest, and we are going to look for the temperature at the acceleration of the body at these times. Now, speed and velocity similar, you understand? Now, we are looking for the velocity. We know that velocity equals to differentiation of s with respect to t. And that's going to be equals to what? Differentiation of s with respect to t is going to give us 3t squared minus 2t, right? 3t squared minus 2t. Sorry, 2t squared. That is, sorry, I made mistake. It's supposed to be 2t squared. 3t cubed, 2t squared. Minus 4t plus 1. This is the differentiation of this particular question. This is the question. This is the real question. So in looking for this, the only way we have seen the speed now, right? The speed is given as 3t squared minus 4t plus 1. We now want to look for the time. The only way we can look for the time here, you will notice that this particular formula is a quadratic equation. Quadratic equation. It's a quadratic equation. You understand? Now, what are we going to do in this case? We are going to solve it quadratically. You understand? Now, what are the factors of 3 multiplied by 1? The first thing we have to do is 3 multiplied by 1. That's equals to 3, right? What are now the factor of 3 whose sum equals to minus 4? That is minus 3 and minus 1. So minus 3 multiplied by minus 1 equals to 3. Minus 3 minus 1 equals to minus 4, right? Which means we are going to be having 3t squared minus 3t minus t plus 1. This will be our distance. So I'm going to bracket it now. Put it inside brackets. Factorize out the common factor. Remember, that is equals to what? So that's equals to 3t squared minus 3t, then minus t plus 1, right? Minus t plus 1 equals to 0, right? Now, the next thing is I can factorize out the common factor here. That is 3 into brackets 3t, that is t minus 1. In this case, it is minus 1 that is common, that is t minus 1. Everything equals to 0, which means my 3t minus 1 or t minus 1 equals to 0, it means my 3t can be equals to 1, or my t can be equals to 1. Divide both side by 3, divide both side by 3. It means my t can either be 1 over 3 or my t equals to 1, which means this is the time that I use in reaching point A to point B within this time. You understand? Now here to calculate the acceleration of the body within these times. I have my velocity. What's my velocity? My velocity is 3t squared minus 4t plus 1. So my velocity equals to 3t squared minus 4t plus 1, right? My acceleration will be equals to what? My acceleration will be equals to 6t minus 4. And what will be my acceleration at t equals to 1 over 3? That is acceleration equals to 6 multiplied by 1 over 3 minus 4. 3 here 1, 3 here 2. That is 2 minus 4. And that's equals to minus 2 meters per second. Minus 2 meters per second squared. And acceleration at t equals to 1. That will be equals to what? That will be equals to a equals to 6 multiplied by 1 minus 4. And that's equals to 6 minus 4. That give me what? That give me 2 meters per second squared. So these are the acceleration at the two times that I calculated. So this is how to apply the knowledge of derivative and higher derivative, especially when it comes to a question like this. In the next video, we are going to be talking about the turning point of a function. And until the next video, subscribe and follow for more. Thank you.